On July 20th, 1969, Neil Armstrong stepped off the bottom rung of the Eagle lunar module and planted his boot into the gray powder of the lunar surface. He said his famous words. The world celebrated. And somewhere back on Earth, a kid watching a fuzzy black and white television set had a very different reaction. Not celebration, not wonder, something closer to a creeping, stomach-dropping dread. Because if a human being could stand on the moon and look back at Earth, a pale blue marble hanging in absolute nothing, then the universe was not just a thing you read about in a textbook. It was real. It was out there. And it was unimaginably, incomprehensibly, disturbingly large. That feeling, the one that sits somewhere between awe and terror, is something that a staggering number of people share. And it doesn't just come from watching the moon landing. It comes from looking up at a clear night sky and really thinking about what you're seeing. It comes from stumbling across a scale diagram of the solar system at 3 in the morning and lying awake afterward. It comes from watching a documentary about black holes and feeling the floor drop out from under you, even though you're sitting on your couch. I've talked about fears of space before on this channel, but today I want to go deeper, much deeper. Because I don't think we've even scratched the surface of how genuinely, legitimately terrifying the universe is. And I mean that in the most sincere possible way. Not as a gimmick, not as a hook. I genuinely believe that if more people truly understood the things I'm about to talk about, not just heard them, but actually internalized them, they would struggle to sleep at night. So let's do that. Let's make sure you struggle to sleep tonight. This isn't an insult. It's biology. Our brains evolved over hundreds of thousands of years to navigate a world where the largest distances we'd ever need to comprehend were maybe a few hundred miles. The distance to the next valley, the width of a river, the height of a mountain. Those are the scales our minds were built for. They're the scales that kept our ancestors alive. Understanding that a neighboring tribe was 3 days' walk east was useful. Understanding that the Andromeda galaxy is 2.537 million light-years away was not. So when we encounter truly astronomical numbers, the brain does something interesting. It gives up. Not obviously, it doesn't throw an error message or shut down. It just sort of nods along and files the number away as big, really big, very, very big. But here's what it does not do. It does not actually generate a visceral, embodied sense of what that bigness means. It cannot. The machinery simply isn't there. And this, I think, is the primary reason space is so unsettling to so many people. It's not just that space is large, it's that space is large in a way that actively defeats your ability to comprehend it, and your brain knows it's been defeated. And that gap, the gap between what you know intellectually and what you can actually feel, is where the fear lives. Let me give you an example of how broken our intuitions get when we try to engage with astronomical scales. If you counted from 1 to 1,000,000, one number per second, it would take you about 11.5 days. Annoying, but doable in theory. If you counted to 1,000,000,000 the same way, it would take you over 31 years. You would age visibly. You might have children. You definitely miss several World Cups. Now count to 1,000,000,000,000. That's 1,000,000 millions. At one number per second, that takes you just under 32,000 years. That's longer than human civilization has existed. That's all of recorded history, multiplied many times over, just to count to 1,000,000,000,000. The observable universe is approximately 93 billion light-years across. The number of stars in the observable universe is estimated at around 200 sextillion. That's a 2 followed by 23 zeros. That number is so far beyond a trillion that comparing a trillion to it is like comparing a single grain of sand to every beach on Earth. Your brain reads that sentence and nods and says, big, and moves on, because there is absolutely nothing else it can do. This is what I mean by the scale problem, and it gets worse the deeper you look. I want to dwell on this for a moment because I think it genuinely matters for understanding why space is so terrifying, and I think most people have heard the term light year enough times that it's lost all impact. Light travels at approximately 299,792 kilometers per second. In the time it takes you to blink, roughly a third of a second, light travels about 100,000 kilometers. In 1 second, it travels nearly 7.5 times around the Earth's equator. In 8 minutes and 20 seconds, it travels from the sun to your eyeballs.
A light year is the distance light travels in one full year of moving at that speed. That works out to roughly 9.46 trillion kilometers, nearly 10 trillion kilometers. That is one light year. The nearest star to our sun, Proxima Centauri, is approximately 4.24 light years away. So even at the universe's absolute speed limit, the fastest anything can move, it would take over 4 years to get there. And Proxima Centauri is our neighbor. It is the closest star we have outside our own solar system. It is, cosmically speaking, right next door. The Milky Way is about 100,000 light years across. Even if you could travel at the speed of light from one edge of our galaxy to the other, the journey would take 100,000 years. And our galaxy is not particularly large. There are galaxies hundreds of times bigger. Now, here is where it starts to get genuinely disturbing. There are objects we can observe in the universe that are so far away, the light we see left them before Earth even existed. We are looking at light that began its journey nearly 14 billion years ago. We are quite literally seeing the deep past, and the object that emitted that light, whatever it was, may no longer exist in any form. The light is still arriving. The source may be long gone. Space is not just big in the way that a country is big compared to a city. Space is big in a way that makes the entire history of human civilization look like a rounding error. The pyramids being thousands of years old seems impressive until you realize that our sun is 4.5 billion years old. And even it is a relatively young star compared to some of the ancient red dwarfs that have been burning for nearly 10 billion years. Everything you have ever known, everyone who has ever lived, every war ever fought, every love ever felt, all of it has occurred in the blink of an eye on a cosmic timescale, on a tiny rock in the outer arm of an unremarkable galaxy, in a universe that is under no obligation to notice us at all.
Here is something that I find uniquely, almost indescribably disturbing about space: the silence. Not just the physical silence, though that is eerie enough. Space is a near-perfect vacuum, which means sound cannot propagate through it. If you were somehow floating in open space outside the atmosphere, the entire universe would be completely, totally, absolutely silent. There would be no ambient noise, no background hum, no wind, no distant traffic, nothing. Just the sound of your own heartbeat and your own breathing inside your suit, and nothing else for literally as far as the concept of as far as extends. That silence alone would be psychologically devastating to most people within minutes. Human beings are social animals who have never in the entire history of our species existed in complete auditory isolation from the natural world. There has always been wind, water, animals, other people. The idea of a silence so total that it contains not one single molecule of sound propagation, that is a silence your nervous system has simply never encountered and is not prepared for. But the silence I'm really talking about is a different kind. It is a conceptual silence. The silence of a universe that is not answering. We have been broadcasting radio signals into space, essentially by accident, since the early 20th century. The first deliberate message aimed at potential extraterrestrial intelligence went out in 1974 from the Arecibo Observatory. We've sent golden records on spacecraft designed to survive billions of years. We have powerful telescopes listening in every direction, monitoring frequencies that an intelligent civilization might plausibly use to communicate. And we have heard nothing. Absolutely nothing. Not a whisper. Not an accidental blip. Not even an anomaly we can't explain that might, charitably, be interpreted as a signal. The universe has maintained a perfect, unbroken silence in response to every attempt we've made to reach out. And here is the really unsettling part. The universe is very, very old, and it contains an almost incomprehensible number of planets in what astronomers call the habitable zone of their stars, meaning conditions that could theoretically support liquid water, and by extension, life. Given the sheer numbers involved, the probability of Earth being the only planet in the entire observable universe to have produced life seems almost vanishingly small. The numbers just don't support it. So either we are somehow extraordinarily special, a cosmic accident of such improbable uniqueness that intelligent life occurred exactly once in a universe containing hundreds of sextillions of stars, or intelligent life does exist elsewhere, and we simply haven't found it yet, or found each other, or been found. Neither option is particularly comforting, because if we are the only ones, then the universe is an unimaginable expanse of cold, empty, lifeless matter, with no one to witness it, no one to understand it, and no purpose we can meaningfully identify. And we are the one improbable accident in the middle of all of it, temporary and fragile and very much alone. And if we are not the only ones, if there are other civilizations out there, then where are they? Why the silence? The Fermi paradox has many proposed solutions, and some of them are deeply unsettling in ways that go far beyond simple loneliness. The Fermi paradox, the question of why, given how large and old and seemingly hospitable to life the universe is, we have found no evidence of other intelligent civilizations, has a range of possible answers. Astronomers and philosophers have proposed dozens of them over the decades, and most of them are uncomfortable, but one proposed answer is particularly disturbing. It's called the Great Filter. The idea goes like this. Somewhere along the chain from simple chemistry to interstellar civilization, there is a step that is almost impossibly hard to cross. A filter. Something that prevents the vast majority of life, maybe all of it, with our single known exception, from making it through. The question is, where in the chain is this filter? Option 1, the filter is behind us. The hardest step, the one that almost never happened, was something that already happened in Earth's past. Maybe the origin of life itself is extraordinarily rare. Maybe the jump from single-cell to multicellular organisms is almost impossible. Maybe the development of complex nervous systems is a freak occurrence. If this is the case, then we are incredibly lucky to exist at all. The filter is behind us, and the reason the universe appears empty is that almost nothing else made it through the early steps. This is comparatively the reassuring version of the Great Filter hypothesis, even though it still implies a universe that is effectively empty of anyone to talk to. Option 2, the filter is ahead of us. The steps that led to us, life, multicellular organisms, intelligence, civilization, might actually be fairly common. Maybe there are millions of civilizations that have reached our stage of development throughout cosmic history, but something happens to essentially all of them before they become spacefaring enough to be detectable across interstellar distances. Some obstacle, some transition, some challenge that no civilization has yet managed to successfully navigate. Maybe it's runaway climate change. Maybe it's the development of weapons powerful enough to cause extinction. Maybe it's something we haven't thought of yet. If the filter is ahead of us, then every step of scientific and technological progress we celebrate is actually just walking us closer to the thing that kills civilizations. This version of the hypothesis is genuinely one of the most disturbing ideas in the philosophy of science. It suggests that the silence of the universe might be a graveyard, that the reason we don't hear anyone else is that they are all already gone, and we are walking the same path toward the same end. There is a version of this that I find especially hard to sit with. Some researchers have proposed that the discovery of microbial life on Mars, a finding that many scientists consider plausible, would actually be terrible news for humanity. Here is why. If we found evidence that life had independently evolved on Mars, it would mean that the origin of life is not the rare improbable step in the filter. Life gets started easily, which would mean the filter is somewhere else, somewhere more recent, somewhere we might be approaching right now. Every time there's a headline about potential signs of ancient life on Mars, there's a small part of me that hopes they find nothing. Let's take a step back from the existential stuff for a moment and talk about something more concrete. Let's talk about stars. Because I think most people have a mental model of stars that significantly undersells how alien and terrifying they actually are. When you look up at a star in the night sky, your brain registers it as a small dot of light, a point, something compact and distant and safe. It's just up there twinkling pleasantly. It doesn't feel threatening. It feels almost decorative. Here is what you are actually looking at. The sun, our star, the one that has nurtured life on this planet for billions of years, the one that feels warm and familiar and life-giving, is a sphere of plasma about 1.3 million kilometers in diameter. You could fit approximately 1.3 million Earths inside it. The surface temperature is roughly 5,500 degrees Celsius. The core temperature is approximately 15 million degrees Celsius. Every second, the sun converts about 600 million tons of hydrogen into helium through nuclear fusion, releasing the energy equivalent of billions of nuclear weapons detonating simultaneously. Prominences, loops and arcs of plasma that erupt from the sun's surface, can reach hundreds of thousands of kilometers. The largest solar flares release energy equivalent to billions of atomic bombs in a matter of minutes. Coronal mass ejections howl billions of tons of charged particles into space at millions of kilometers per hour. And our sun is a fairly average, fairly unremarkable medium-sized star, a yellow dwarf sitting quietly on the main sequence. It is not impressive by stellar standards. There is a class of stars called hypergiants. The largest known hypergiant, UY Scuti, has a radius approximately 1,700 times that of our sun. If UY Scuti were placed where our sun is, its surface would extend past the orbit of Jupiter. Jupiter, the giant planet so large that all the other planets in the solar system could fit inside it many times over, that planet would be inside the star. Earth would be incinerated at a distance of 150 million kilometers. But even hypergiants are comprehensible things in a sense. They're big, but they're objects. They have edges. They have defined space. Then there are neutron stars. A neutron star is what remains after a star between roughly 8 and 20 times the mass of our sun dies in a supernova explosion. The outer layers blow up in an enormous explosion and the core collapses under its own gravity until the atomic structure of matter itself gives way. Electrons and protons are crushed together to form neutrons.
What's left is an object roughly 20 kilometers across, smaller than many cities, that contains a mass greater than our entire sun. The density of a neutron star is so extreme that a single teaspoon of its material would weigh approximately 10 million tons on Earth. The gravity at the surface of a neutron star is approximately 200 billion times stronger than Earth's gravity. The magnetic field of a neutron star can be so intense it would be lethal at a distance of 1,000 kilometers. Some neutron stars, called pulsars, spin hundreds of times per second and emit beams of electromagnetic radiation with the regularity of a cosmic metronome. And then there is the thing that neutron stars sometimes become. When a neutron star's mass exceeds a certain threshold, even the structural integrity of neutron matter cannot hold. The collapse continues past any state of matter we understand, into a singularity, a point of effectively infinite density, a region of space where the curvature of space-time becomes so extreme that not even light can escape. A black hole.
I have talked about black holes before, and I will never stop talking about them because they are genuinely the most disturbing objects in the universe. And I feel that strongly. Let me be precise about what makes them so unsettling to me specifically, because I think it goes beyond the obvious "they're big and they'll kill you" explanation. What disturbs me most about black holes is not their size, though their size is absurd. It's not even their lethality, though that's certainly a factor. What disturbs me most is that a black hole represents a fundamental breakdown in the normal rules of the universe. It is a place where the physics we use to describe everything else simply stops working. The equations break down. The models produce infinities. We don't have a coherent theory of what's actually happening inside one. We don't know what happens to matter that falls past the event horizon. We have models and theories and competing hypotheses, but no confirmed understanding. We don't know whether the information encoded in that matter is preserved or destroyed. And that question, the black hole information paradox, has been one of the most contested problems in theoretical physics for decades. Some of the smartest people who have ever lived have argued about this. Stephen Hawking famously changed his position on it. It remains genuinely unresolved. At the center of a black hole, according to our best current theories, is a singularity, a point of infinite density and zero volume, where space-time curvature becomes infinity. Infinity in a physics equation is typically not a good sign. It usually means the theory is failing, that you've pushed it past its valid range, that something else is happening that the current framework cannot describe. When a calculator divides by zero, it shows an error. When physics equations produce infinity at the center of a black hole, we don't have an error message to show. We just have the infinity and the uncomfortable acknowledgement that we don't know what it means. There's a concept called spaghettification that I want to mention because the name is playful, but the reality is genuinely nightmarish. As an object falls toward a black hole, the gravitational pull on the near side of the object is significantly stronger than the pull on the far side. This differential in gravitational force stretches the object in the direction of fall and compresses it sideways simultaneously. If the object is a human being, you would first experience mild tidal forces you might not even notice, then increasing discomfort, then agony as your body begins to physically elongate, then structural failure, your body pulled apart at the molecular level, stretched into a thin stream of particles raining into the singularity. The term spaghettification is technically accurate and also completely inadequate. For stellar mass black holes, this happens quickly, and death from radiation and heat would precede the worst of the tidal forces in most scenarios. But for supermassive black holes, the monsters at the centers of galaxies, billions of times more massive than our sun, the tidal forces at the event horizon are actually relatively mild because of how large the event horizon is. You could theoretically cross the event horizon of a supermassive black hole without immediately being spaghettified. You might not even notice the crossing, except that you are now inside the event horizon and leaving is permanently and fundamentally impossible. Then you fall, and the singularity is in your future, not in the direction you're facing, not somewhere you could turn away from. It is your future, in the same way that tomorrow is your future. You cannot avoid it any more than you can avoid the passage of time, because inside the event horizon, the singularity is not a location in space, it is a location in time, and time unfortunately moves in only one direction. Meanwhile, outside the black hole, time dilation effects mean that the entire lifespan of the universe would tick by in what feels to you like hours. Everyone you have ever known or loved or heard of would be born, live, and die, and be so long forgotten that the very stars that shone when they lived would burn out and go cold, all in the time it takes you to fall. The universe would end, not in any dramatic way, just in the slow heat death of entropy, the gradual dimming of everything, and you would still be falling. I find that thought, specifically that thought, more disturbing than almost anything else I know about the universe. Not just the dying part, the temporal isolation, the complete severance from everything and everyone, watching the universe play out in fast forward through increasingly warped spacetime, and then nothing. I want to talk about something that doesn't get discussed as much in conversations about space, the emptiness.
We talk about how many stars there are. We talk about galaxies and nebulae and black holes. We fill the universe with interesting things when we describe it. But the overwhelming majority of the universe, by volume, by an almost unimaginable margin, is nothing, absolutely nothing. Not dark matter, which is at least something. Not even dark energy, just void, empty space, a vacuum more perfect than anything we can create in a laboratory, stretching in every direction essentially forever. Between stars, even in the relatively dense spiral arms of a galaxy like the Milky Way, the average distance between stars is about 4 light years. I described earlier what a light year means. 4 of those in every direction before you reach another light source. In the space between stars, you would be surrounded by such complete darkness that the term darkness feels inadequate. Not the darkness of a room with the lights off, where there's still ambient light from outside and your eyes adjust and you can eventually see shapes. True, absolute, total darkness in every direction, with the nearest light source 4 years of travel at the speed of light in any direction you choose. Between galaxies, the distances are incomparably larger. The void between the Milky Way and the Andromeda Galaxy, our nearest major galactic neighbor, is about 2.5 million light-years across. In that void, there are almost no stars, a few scattered stars maybe, gravitationally ejected from their home galaxies long ago, drifting alone in the intergalactic dark, but mostly nothing. And between galaxy clusters and superclusters, there are structures called cosmic voids, regions of space with almost no galaxies at all, that can span hundreds of millions of light-years. The Bootes void, one of the largest known, is about 330 million light-years across, a spherical region of space containing almost nothing. If you were in the middle of the Bootes void, the nearest galaxy would be about 100 to 150 million light-years away in any direction. On a clear night, instead of a sky full of stars and the faint smear of the Milky Way, you would see almost nothing. A few smudges of light at enormous distances. The night sky would be virtually black. There's something psychologically distinct about emptiness compared to other sources of fear. Most fears are about things that can hurt you. Predators, heights, disease. Emptiness can't hurt you. It has no properties. It just is, an absence that extends without limit. And yet the contemplation of it produces in many people a feeling I can only describe as a kind of vertigo. Not the physical sensation of being up high, but the conceptual sensation of recognizing that everything familiar, everything solid, everything real is separated from everything else by enormous portions of absolutely nothing. We are not just small, we are isolated. We are specks of matter clinging to a rock that is itself a speck, surrounded by voids so vast and so empty that the distances involved genuinely cannot be internalized by any human mind.
Space is one abyss. Time is the other. The universe is approximately 13.8 billion years old. That number has become familiar enough through repetition that it may not land with the weight it deserves. Let me try to give it some. Modern humans, Homo sapiens with anatomy essentially identical to ours, have existed for roughly 300,000 years. Agriculture, which gave rise to civilization, cities, writing, and everything we think of as human history, is about 12,000 years old. Writing itself is only about 5,000 years old. Everything we know, every name we remember, every story we've preserved, every achievement we celebrate, occurred in the last roughly 5,000ths of 1% of the time since the universe began. Before us, and before the solar system existed at all, which only formed about 4.5 billion years ago, the universe had already been running for more than 9 billion years. The stars that formed in the early universe burned through their fuel, exploded as supernovae, and scattered the heavy elements that would eventually become our sun and our earth and our bodies. Those stars lived their entire lives and died billions of years before Earth formed. We are built, literally, from the ash of dead stars, stars that burnt out before our solar system was even a nebula. And the universe is not done, not remotely. The current age of the universe, 13.8 billion years, is in a very real sense just the beginning. The era of star formation will continue for trillions of years. Eventually, far in the future, the last stars will burn out. After that, for an almost unimaginable stretch of time, the universe will be populated only by cooling remnants of dead stars, white dwarfs slowly fading, black holes slowly evaporating through Hawking radiation, and cold darkness. This era, the so-called degenerate era, the black hole era, and then the dark era, will last far longer than the current stellar era has lasted so far, on timescales that make the current age of the universe look like a single tick of a clock. I find deep time almost more disturbing than deep space. Space you can at least visualize, poorly, in a spatial way.
Time stretches behind and ahead of us in ways that feel personally threatening in a manner that distance does not. Because we exist in time, we move through it, we age, we die, and the universe was here for billions of years before us and will continue for trillions of years after. And our entire existence, every moment of human experience, is a thing so brief on the cosmic calendar that there isn't really a metaphor adequate to capture its brevity. Carl Sagan famously compressed the history of the universe into a single calendar year, the cosmic calendar, in which the Big Bang occurs on January 1st and the present moment is midnight on December 31st. On this scale, the Milky Way forms in May, the solar system forms in September, the first life on Earth appears around September 21st. Multicellular life doesn't appear until mid-December. Dinosaurs appear on December 25th and go extinct on December 30th. All of recorded human history, every pharaoh, every war, every empire, every symphony, every scientific discovery, occurs in the last few seconds before midnight on December 31st. The last few seconds. That's not just a poetic statement. It is an accurate representation of our place in time. Everything we have ever done or thought or felt has happened in the last few seconds of a year-long story in which we play, at most, an extremely minor role. On February 14, 1990, the Voyager 1 spacecraft was approximately 6 billion kilometers from Earth, beyond the orbit of Neptune, heading out of the solar system, when it turned its camera back toward the sun and took a series of photographs. At Carl Sagan's request, these photographs captured the inner solar system from the outside. In one of those photographs, Earth appears as a tiny point of light, smaller than a single pixel, a pale blue dot suspended in a beam of sunlight against the darkness of space. This image is often presented in a context of wonder and perspective. Carl Sagan's accompanying meditation on it is one of the most beautiful pieces of writing about our place in the universe. He speaks about how that pale dot contains everything we have ever known, how it calls us to treat each other with greater kindness, how it illustrates the fragility and preciousness of our shared home. All of that is true and moving and worth sitting with. But there is another way to look at that image, and I think it is equally honest, and it is considerably more frightening. In that photograph, Earth is not just small. It is invisible without knowing where to look. It is indistinguishable from a dust speck or a sensor artifact. It occupies less than a pixel of a photograph taken from a spacecraft that, at the time, had only just barely left the neighborhood of our own solar system. The nearest star is still 4 light-years away. The nearest galaxy is 2.5 million light-years away. The observable universe is 93 billion light-years across. We, everything we have ever been, everything we have ever built, everyone who has ever lived, are a speck of dust in a single beam of sunlight in a photograph taken from within our own solar system, before you even try to contextualize us against the scale of the galaxy, or the local group, or the Virgo supercluster, or the observable universe. There's a word that sometimes gets used to describe the feeling this image can produce: the overview effect. Astronauts who have seen Earth from space report a sudden, overwhelming shift in perspective. The petty divisions between nations and people seem absurd. The fragility of the biosphere becomes viscerally apparent. The unity of all human experience is suddenly obvious. But there's another effect, less discussed, that some astronauts also report: a profound and sometimes destabilizing recognition of vulnerability, of exposure, of just how thin and breakable the membrane of atmosphere is that makes our world habitable, of how the blackness surrounding that fragile bubble is completely and utterly hostile to life in every way a thing can be hostile. No oxygen, no pressure, extreme temperature gradients, lethal radiation, and it begins, in some cases, not 2 meters outside the spacecraft walls. Space doesn't want you there. That's not anthropomorphism. Space has no wants. It's worse than that. Space is entirely, constitutionally, structurally indifferent to your presence or absence. It operates on its own rules, at its own scales, on its own timelines, and you are not a factor in any of its calculations. Here is the thing that I genuinely believe is the most unsettling aspect of our current understanding of the universe. We don't know what most of it is made of. All the ordinary matter in the universe, stars, planets, gas clouds, black holes, you, me, everything we have ever directly detected or observed, accounts for approximately 5% of the universe's total energy content. 5%. The remaining 95% is made up of things we cannot directly observe. About 27% is what physicists call dark matter, a substance or phenomenon that has gravitational effects on galaxies and galaxy clusters, but that does not interact with light or normal matter in any way we have yet managed to detect. We know it exists because without it, galaxies would fly apart. They spin too fast for their visible mass to hold them together. Dark matter must be providing additional gravitational cohesion, but we don't know what it is. We have not detected a single dark matter particle despite decades of trying with increasingly sensitive instruments.
And then there's the remainder. About 68% of the universe's energy content is something called dark energy, a term that is essentially a placeholder for we have no idea what this is. It is the dominant component of the universe. It is responsible for the accelerating expansion of space itself, and we know almost nothing about it except that it exists and that it has effects we can measure. Its fundamental nature is completely unknown. So to summarize, we have a detailed, precise, and experimentally confirmed understanding of approximately 5% of what the universe is made of. The other 95% is, in the literal sense, a mystery. We have given the mystery names, dark matter, dark energy, because giving things names make them feel more knowable, but the names are labels on boxes that are completely empty of explanation. This should be humbling, and it is, but it's also frightening, because it means that our picture of what the universe is and how it works is not just incomplete, it is overwhelmingly incomplete. We have at best a partial description of a small fraction of reality. The most fundamental questions about the nature of the universe, what most of it is made of, why the expansion of space is accelerating, whether the laws of physics are the same throughout, remain completely unanswered. And beyond the darkness, dark matter, dark energy, there is the boundary of the observable universe. Because the universe is expanding, there are regions of space where everything is receding from us faster than the speed of light. This is not a violation of relativity. Nothing is moving faster than light through local space. It's the space between us that's expanding. The light from those regions will never reach us. They are in a physical sense outside our universe. We cannot see them, we cannot detect them, we cannot know what is there. The observable universe is a bubble, and outside the bubble is a larger universe of unknown size. It could be finite, it could be infinite. Current cosmological models suggest it is at least 250 times larger than the observable portion, possibly vastly larger. Some versions of inflationary cosmology suggest that the total universe is exponentially, almost impossibly larger than the observable portion, possibly infinite, and we will never, ever know what is out there in the regions beyond our horizon, because the information will never reach us. This is not a temporary limitation we might overcome with better technology. It is a fundamental feature of the universe we inhabit. There is a hard boundary to what we can in principle ever know, and beyond that boundary lies something enormous, possibly infinite, about which we are constitutionally incapable of gaining any information whatsoever.
I touched on the Great Filter earlier, but the Fermi paradox has some other proposed solutions that I want to revisit because I don't think they get taken seriously enough as genuine sources of dread. One proposed explanation is the zoo hypothesis, the idea that intelligent extraterrestrial civilizations are aware of us but have chosen not to make contact for reasons we can only speculate about. Maybe they're observing us. Maybe they consider contact to be harmful to developing civilizations. Maybe we're a nature preserve. Maybe there's a galactic treaty about non-interference with pre-spacefaring species. This one has a slightly warmer reception in popular culture, probably because it implies we're being watched over in some sense. But think about it from the other direction. If this is true, then there are beings, possibly many, possibly vastly more intelligent and capable than us, who have looked at us and decided we're not worth talking to yet. We are the primitive species behind the glass, and we have no control over when or if that glass ever comes down. We cannot force contact, we cannot signal in any way that would be compelling to a civilization that can already see everything about us. We simply wait, and they watch, and we don't know if that situation will ever change. Another proposed explanation is the dark forest theory, described by the Chinese author Liu Cixin in his science fiction novels, and now discussed seriously by some scientists and philosophers. The basic idea: the universe is a dark forest, and every civilization in it is a hunter. Resources in the universe are finite. Advanced civilizations know this. Any civilization that announces its existence is announcing a potential competitor or a potential threat. Any sufficiently advanced civilization will therefore conclude that the safest strategy is silence, and that any other civilization it detects should be eliminated before it can develop into a competitor. In this model, the silence of the universe is not the silence of emptiness, it is the silence of predation. Every civilization maintains radio silence out of fear, and when you broadcast your presence, as we have been doing for decades, you are not calling out to friends, you are stepping into a dark forest and shouting your location. I want to be clear, the dark forest theory is a hypothesis, one of many. There are good arguments against it. The fact that we've been broadcasting for over 100 years and have not been visited or destroyed might be considered evidence against it. But the theory exists, it is taken seriously by smart people, and the fact that we cannot rule it out is, I would argue, genuinely worth thinking about. Here's a final concept I want to sit with, because I think it is genuinely one of the most profound and disturbing ideas in cosmology, and it doesn't get discussed enough outside of academic contexts. We experience the universe as it exists right now. But the universe we see, the stars we observe, the galaxies we photograph, the light that reaches our eyes and our telescopes, is not the universe as it exists right now. It is the universe as it existed in the past. The moon we see is the moon as it was about 1.3 seconds ago. The sun is as it was 8 minutes ago. The nearest star is as it was 4 years ago. When we look at the Andromeda galaxy, we see it as it was 2.5 million years ago, before our species existed. The most distant objects we can observe are as they were billions of years in the past. We have no idea what the universe looks like right now, at this precise moment, because right now has no meaning at cosmological distances. Relativity tells us that simultaneity is not universal. There is no single moment called now that applies everywhere across the universe. The concept of the current state of the universe is not a coherent one in the framework of general relativity. We are, in a profound sense, temporally isolated. We can only ever see the past. We know that galaxies we observe have changed, evolved, possibly collided with others, possibly died out in the billions of years since the light we're seeing left them. We know that some of the stars we see in the night sky may already be dead, their final light still making its way toward us across unimaginable distances. We are receiving postcards from a universe that may have long since moved on. There is a star visible to the naked eye in the night sky called Betelgeuse. It is in the constellation Orion and is one of the brightest stars we can see. Betelgeuse is what's called a red supergiant, a star in the late stages of its life, massive enough that it will eventually end in a supernova explosion. Astronomers have long speculated that Betelgeuse could go supernova at any point in the next few 100,000 years. If it does, it will briefly be the brightest object in the night sky after the moon, visible in daylight. But Betelgeuse is about 700 light-years away. The light we see when we look at Betelgeuse is 700 years old. Betelgeuse might already have exploded. The supernova might have already happened. The shockwave and the light from the explosion might right now be traveling toward us, and we won't know about it until the light arrives, potentially decades or centuries from now. We are not observers of the present universe. We are archaeologists of light, sifting through the records of a past that spans billions of years, trying to reconstruct a picture of something that is constantly, relentlessly changing in ways we cannot see. I want to come back before I finish to something closer to home, because I think we too easily pass over the things in our own cosmic backyard in our rush to discuss the more dramatic distant objects. The sun. Our sun. It is 150 million kilometers from Earth. If you could drive to the sun at highway speed, 100 kilometers per hour, it would take you 171 years to get there. The Earth orbits this star at a speed of approximately 107,000 kilometers per hour, nearly 30 kilometers every second. We are always in motion, constantly hurtling around a nuclear furnace at incomprehensible speed, and we feel none of it. The universe conspires to keep us completely unaware of our own motion through it. There are stars that make our sun look like a marble. The star Ui-Sooty, which I mentioned earlier, has a radius so large that light would take about 7.5 hours to travel from one side to the other at 300,000 kilometers per second. The largest known stars are so large that the phrase "so large" stops feeling like it means anything. And all of this, everything I have described, every terror and wonder and incomprehensible scale, is happening in a universe that has been running for 13.8 billion years and will continue running for trillions more, with or without us, indifferent to our presence, indifferent to our curiosity, indifferent to our fear. I've spent a lot of time in this video trying to make you afraid. Not irresponsibly afraid, not in the way that makes you want to never look up at the sky again, but genuinely, accurately afraid. Because I think accurate fear is something we owe the universe. The universe is not a comfortable or welcoming place. Recognizing that honestly seems more respectful of the truth than wrapping it in constant reassurance. But here's the thing, fear and wonder are not opposites, they're neighbors. They are two different responses to the same fundamental recognition that the universe is vastly larger, older, stranger, and more complex than we can comfortably contain. Fear says, this is too big and I am too small. Wonder says, this is too big and I am too small, and I'm going to look at it anyway. Every civilization that has ever existed has pointed its telescopes, literal or metaphorical, outward. Every culture has developed cosmologies, mythologies, and scientific frameworks for understanding the heavens. The impulse to look up is one of the most consistent things about our species. We are afraid of the void, and we look at it anyway. We are terrified by the scale, and we measure it anyway. We know the silence suggests emptiness or danger or something we can't name, and we transmit signals into it anyway. There's something almost irrational about that, and also something that seems to me to be genuinely beautiful. Voyager 1, the farthest human-made object, is currently moving through interstellar space. It has left the heliosphere, the bubble of influence created by our sun's solar wind. It is in the space between stars. It carries on its side a golden record containing sounds and images from Earth, greetings in dozens of languages, music from across human cultures.
It is a message in a bottle thrown into an ocean we cannot see the far shore of. The probability of it ever being found by anyone who could understand it is almost incomprehensibly small, and yet we sent it. And I think that matters. Not because it will definitely be found, not because it proves we are optimistic or brave, but because the act of sending it, the act of reaching out into the silence, knowing the odds, and reaching anyway, says something about what we are. We are beings who know our own smallness and refuse to be defined by it. We are beings who look into the abyss, and even when the abyss looks back, keep looking. The physicist Richard Feynman once said that the same thrill that makes the universe seem terrifying also makes it magnificent. The vastness that produces the vertigo also produces the aurora borealis, the spiral arms of galaxies, the iridescent surface of Saturn's rings lit from behind by the sun. The scales that diminish us also contain